say half an hour or so, I'll talk about very, very basic things. And then after that, maybe some applications. And we will tell you how to usually, how in general, the companies who are using data science, what do they do? What is their mode of functioning? And what are the applications part? So today we are thinking of after that seeing some applications in the retail. And in binary logistic regression. And this actually is very much part of a data science syllabus. Well, we have been around for quite some time and we have trained 150,000 people around the world. And most of them have been into statistical analysis, Lean, Six Sigma, project management, etc. So data science was a natural progression where we would like to further enhance. Further, we would take take our knowledge to the next level. And when the data science happened around 7 or 8 years, it was natural for Anexas to launch these data science training programs. So let us see what is data science. And first of all, first question people ask, let me, in fact, let me ask you, as per you, what do you think is data science? As per you, what do you think is data science? Yes. So what is your understanding of data science? Well, so I see very few answers here. Okay. So it means measuring current result. Okay. So Kamal Hassan is telling measuring current results. So yeah, not only measuring, but also analyzing and making sense out of it and using this analysis, whatever insights we are getting from the data, we would like to use it to our advantage to achieve a certain goal. And that is what is data science. Now, one of the course benefits when you attend any data science course, and especially a structured data science course like basic data science, you become a data scientist. If you attend a basic data science course also, you become a data scientist. Then there are 3 levels: basic, intermediate, and advanced. I'll talk about more at a later stage. But now, the best part about becoming a data scientist is, and in today's world, as you might have known by now, and I don't have to tell you that the next decade belongs to data science. Sometimes people say that next century belongs to data science, but I would say it's like, I will not make that statement, but at least next decade belongs to data science. And all the people who know data science are going to progress faster. In fact, they say that data is the new oil. And the countries who master data science will become, the countries who master data science will be the most powerful countries. As a data science professional, you have to learn Python. You learn machine learning and statistics. You learned natural language processing. You also talk about artificial intelligence. And what are the connections? What exactly data science and artificial intelligence is, how they are connected? Let me explain that also to you. So first, let us understand what is artificial intelligence. First, let us understand what is intelligence. Intelligence is the computational part of the ability to achieve goals. So suppose you are at one state, you are at state A, and you want to reach state B. Because you are at state A and you want to reach state B, there's a gap, and which we define as a problem. Yeah. So what is intelligence? Intelligence is a computational part of the ability to achieve goals. So from A to B, I need to, I need to have some ability so that I can achieve the goal. So I have got a current state and I have got a desired state, and using some tactics and statistics and some little bit of the data which I've collected based on the past data which I've collected based on that experience, and experience is nothing but your past data. Based on that, applying some logic, I achieve the desired state, and that is what is intelligence. Now it is very complicated definition of intelligence, and before we move to the move further, let me also describe what is artificial intelligence. Now, if instead of a human being, a machine is capable of achieving a certain desired goal, yeah, that is known as artificial intelligence. So study and design of intelligent agents is artificial intelligence. So let us try to understand this a little bit better way. In AI, what we are trying to do is we are designing agents. So to understand agents, let's like as a human being, let's imagine ourselves as a human being. We perceive the environment through some sensors, that is our eyes, nose, ears, etc. And this information which is received from the sensors, which is perceived by the sensors, is processed within our brains. And once it is processed within the brain, through the effectors here, it would be hands, legs, sometimes maybe the tongue, the way of speech. We act on the environment. So once again, we have an environment. We perceive the environment using sensors. The information which is received or perceived through the sensors is processed in our brain. Brain has got some data. Brain has got some data stored in your brain, stored in your mind, and also there are certain condition action rules in your minds. Like if this happens, then you should do this. Based on those condition action rules, you perceive the environment and you act on the environment through the effectors. Now, AI is an art and science of creating these agents, artificial intelligence agents. So this could be a simple reflex agent where it senses the environment, it understands how the world is like now and what actions I need to do, and then how, using a condition action rule, I will act on the environment. Or there could be some advanced agent, which we call it as utility-based agent. So how I program the agent is the way human minds are programmed. They are told to optimize or increase the utility points, so that the agent is motivated to increase the utility points. So to give a simple example, as a human being, for us, the utility points could be money. Yeah. So we will be doing those actions where we try to maximize the receipts of the money. For a student, the utility point could be, in a school student or for a college student or a school student, the utility point is scores or the marks. He would like to, his or her actions would be totally focused on how I can increase my marks in the examination. Yeah. So similarly, if I want to motivate a machine to achieve certain action, so I can program in such a way that the desired actions will deliver more utility points. So something like that, if you are doing, we call it as utility-based agent. Now, just wanted to talk about AI basics. I'll not go into the very much history of AI, etc. because today our focus is on the data science. And also, I would like to invite very soon, I'll be joined by Rishabh. And once Rishabh joins in, and just let me know once Rishabh joins in. So then in that case, I will ask him to share some practical examples, because Rishabh is a practitioner. I'm more like a trainer. So I teach theoretical statistics, but he would tell you what are the practical applications of those statistical concepts. In other programs, I have spent a lot of time in teaching you algorithms. Today, I'll not spend too much time in teaching the algorithms. Let's say, but today the focus will be more on learning the data science part, and that too applications parts of the data science. But yeah, one Turing test you should know. What is a good AI agent? How do I qualify something which you have created as an AI agent? We'll say that it is artificially intelligent if, let's imagine this is our machine which we have created. This is the agent which we have created, represented by A. And the B is the human being. So A is the agent, B is the human being, and C is also a human. Now, C interacts with both A and B. And this A and B are sitting in closed rooms, and C doesn't know which room is the human and which room is the machine. And if C starts interacting with both A and B, and C cannot differentiate which is a human and which is a machine, in that case, we say that yes, that is artificial intelligent agent, artificial AI agent. So if C gets confused, that means it is perfect AI agent. Otherwise, we'll say, there are a lot of improvements need to be done on the AI. And John McCarthy is considered as the father of AI. Well, I'll not go too much into the details of history. In another program, in one of our previous programs, if we have got multiple recordings of our AI training programs and introduction programs over the last 2 years in our Anexas YouTube channel. Please feel free to subscribe that channel. You'll get a lot of information, and especially for those who have never undergone any training in data science, these programs are very much useful. We also have got a lot of material on statistical tools and techniques and quality tools and techniques also. If you are interested, you can just watch those videos, and these videos and this knowledge is all free. And feel free to subscribe. Just you click on the subscribe button of Anexas YouTube channel, and you will get access to a lot of videos. Okay, so coming to the main branches of AI, coming to the present. So there are various branches of AI: robotics, vision systems, NLP, natural language processing, neural network, expert systems. Let us see one by one. Expert systems is something where I download the information from an expert. See, this expert could be an engineer, chartered accountant, physician, anyone. A knowledge engineer downloads all the information, creates a knowledge base, and then we create an inference engine, again, based on the condition action rule, like if this happens, then what you need to do, else, if, then else statements. Based on that, you create some logic, and a user who may not be an expert, when it interacts with this particular expert system, this is known as he will get all the information, and this whole system is known as expert system. Lots of information, lots of examples of expert systems are there. Most popular is the IBM's Watson. Some of you might have heard of it. Have you heard of IBM's Watson? Anyone heard of IBM Watson? Okay, not many people have heard of. Okay, it doesn't matter. Okay, IBM Watson is an expert system which has got almost all the information. It's like a chat GPT, you can say. Chat GPT is a recent one, but IBM Watson has been around for the last 30 years. Many times it has participated in some games like, I think if you heard one news around 20, 30 years ago, a Deep Blue, which was a computer program or a machine, AI agent, you can say, was able to defeat the world chess champion. Yeah. So this is an example of AI agent. So similarly, Watson designed by IBM, has won many awards, played many mind games, and every time it becomes a winner. So it can easily replicate a human brain. It can think like a human brain. It has got almost all the information of all the domains from all the industries. So that is just what there's something called which is very much used by the industries. Another example could be like Donald shows the following disorders: headache, body ache, nausea. What exactly is wrong with Donald? So here AI has the answer. Artificial intelligence has the answer. And here an expert system, this is the actual picture of IBM Watson. Yes, the supercomputer, which has got all the knowledge in the world. Yes, so that's stored in this. And any company can pay monthly basis, some fee, and get access to this. And of course, they can. It will look like you're interacting with an expert. IBM and Watson, an expert system. Just to give an example. Okay, I think due to lack of time, I will not give you many videos or examples. I would rather show you the one which will be a little bit more useful for you. So, similarly, the way we learned natural language in our childhood, if we teach the machines also in the same way, machine will be able to speak, machine will be able to write, and machine will be also able to understand the speech. So a typical example is in a sentence phrase, which is SP, sentence phrase. What happens? Right in childhood, we were taught every sentence phrase has got a noun phrase and a verb phrase. Yeah. And the noun phrase comprises of an article and a noun. And similarly, the verb phrase comprises of a verb and a noun phrase in turn. And the noun phrase again comprises of an article and a noun. Now, these are simple grammar which we learned in school, although we may have forgotten, but we were taught. Every sentence phrase has got a noun phrase and a verb phrase, etc. Similarly, if I teach the same thing to machine can figure out, like for example, the doctor examines the patient. See, the doctor is the noun phrase and examines the patient is the verb phrase. And even in verb phrase, you have got a verb and a noun phrase. So in that case, examines is the verb and the noun phrase is the patient. The is an article and N is the noun. But this is a simple logical structure of every sentence in English or any language for that matter. Now, if I put all the vocabulary, if I put all the meanings of the words, machine can act as if it is a human being. Because the way we have learned, it is the same way, right? So it will understand as well as it will be able to speak. NLG is about natural language generation and NLU is about natural language understanding. So both NLU and NLG, they are part of NLP. NLP means natural language processing. A more popular full form of NLP is, I think, neuro-linguistic programming. It has nothing to do with this NLP, right? Please understand this. Great.
The healthcare community is changing, driven by the need to make.
See, in using NLP, you can even interact with the machine.
Information.
So see, every AI agent is actually a combination of expert system, NLP, and later on, I will talk about some more types of machine learning and deep learning algorithms. So it's a combination of multiple research areas of AI. See, NLP can also do something called a sentiment analysis. Sentiment analysis based on the keywords, it can capture which kind of sentiment. Is it a happy, a happy paragraph or something which is providing an information, or it is a political content, whatever. It can easily analyze the
our analysis.
Any type of text. So that is one thing. Robots, I will not talk too much about it. Everyone knows about robots. There's a difference between AI programs and robots. Robots can act on the environment while the programs cannot.
Robotic surgery involves using this instrument, the Da Vinci robot,
robots,
which is a
lots of machines, a lot of work of human beings. So that was about robots. Now, the interesting part nowadays is neural networks. Neural networks, a human brain is composed of 100 billion neurons. And I hope many of us have studied neurons. It has got dendrites, it has got axons, it has got information transfer at the synapses. How the memories are created when I show a pen. Let's say, go back to your school days and your teacher used to show a pen saying this is a pen, P-E-N, pen. So a memory pathway was created, which comprises of, say a few hundreds of neurons. And of course, neurons, again, have dendrites, axons, and synapses. And as a person learns, the myelin sheath on the axons thickens, and that's how the memory also becomes, memory increases. Like you know that this is a pen. Say, for example, if I tell you every day, 3-4 days, that this is a pen, this is a pen, this is a pen, after some time, the myelin sheath on the axons of that particular memory pathway will increase so much. It will thicken so much that this memory will become a belief. And it is very difficult to erase that memory, right? So similar thing, we can do it with the ANN, artificial neural network, where silicons and wires act like living neurons and dendrites. Nodes imitate the neurons, and each node takes inputs, process data, and passes on to other nodes. The links carry the weights. And based on the certain functions, so these are the weights. Based on the weights, the machine can learn using the artificial neural network, ANN, and it can start, after it learns, it can start making predictions. It may start making correct statements. It can start giving correct results. So this is how a typical neural network works. So in layman's language, if you show an input and put some artificial layers, layers of neurons in between, based on the complexity of what needs to be learned, the number of layers can change. Typically 2 to 3 layers are good enough. Sometimes 4 to 5 layers are good enough. And when you come to our sessions, you will come to know that it's so easy to create these layers. It's so easy to create these artificial AI agents. There's no real rocket science in it. It's very, very simple. Although you have to put a little bit of effort in learning certain new concepts. But if you are ready to do that, you can also master the neural networks. You can create your own AI agents. And that's what a lot of people are doing in the world today. So based on that, once the machine learns, this neural network models learn from examples. After some time, an unlabeled photo, when it is shown, the machine will tell you that this is a cat, because it's already learned based on certain features how to recognize a cat. Okay. So there are different areas: supervised learning, unsupervised learning, reinforcement learning. Supervised learning means you have the data, trainer data. You supply the data to the machine. Machine learns, creates an algorithms. Using algorithms, it could be regression, it could be multiple regression, it could be logistic regression. Those who have attended our green belt and black belt training programs, they know about these algorithms. Those who have not, it's don't worry. They are very simple. We can explain this really well. Of course, today, in one of my other program, I have already done it. Anyone from healthcare industry? Is there anyone from healthcare industry? Okay, so Mohammed Muzammil, you are from healthcare industry, right? So I have also done. I have also given a 2-hour presentation. I had given an international medical center about AI in healthcare, basic data science and AI in healthcare. I would be happy to actually give you the. Can you please put Naveen? Can you please put the chat in the chat box, that link? So please watch that. In fact, I'll be happy to play a few portions of that video, which are of course relevant. I've also talked a lot of things, whatever I'm planning to teach you today. A lot of things I've taught in that program as well. So if I were to actually, let me. So before we go for the applications part today, although we are not talking too much about healthcare, but that program talks totally devoted to healthcare. And so let me play some videos, some little bit portion of that video. Yeah. Network. I have input layer, then hidden layers, and then I have got the output layers. So I have, based on certain inputs, say for example, I can give the age, I can give the say glucose levels, I can give the let's say BMI index, and based on that, I will train my machine to tell me whether this person has diabetes or not. So I've got two outputs: he has diabetes or he has no diabetes. And the best part is I can add on as many layers. I can start with one layer. Then if I'm getting the right results, good. If I'm not getting the right result, desired results in the first few minutes, then I will increase the number of layers from 1 to 2. Or after 2 or 3 layers addition, you will see that we are getting, the machine is giving me good layers. It hardly takes sometimes 20 minutes or 1 hour to learn. It is as low as that. And it is as simple as that. I would love to I would love to show you, if I had a little bit more time, some of the websites where all of us can put this. We can create and artificial neural networks. I can keep on adding the layers and see how many layers are giving me the best result, and it can identify the objects. It is it looks complicated when you look at the first time, but it's very, very easy. Those who have done it, they will agree with me. I see some of the people here. You have data science intern also. I think he must be understanding. I'm not using jargon as much as possible, and he must be understanding what I mean. If you want to visualize this, and when I'm seeing when I'm showing you, don't think that it's very, very complicated. It's very, very simple. So I just told you the same thing. You have got the input layer. So let us say I want to train my machine to recognize, let's say, a number. Let's say a number, maybe let me talk about this here. Yeah.
Now jumping over to the last layer, this has 10 neurons, activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between, called the hidden layers, which, for the time being, should just be a giant question mark for how on earth this process of recognizing digits is going to be handled.
Now, just let me tell you that it may look a little complicated. By the way, these are all our assumptions. We see these things happening, so we assume. We don't know actually what exactly these hidden layers do. No one has seen that. This is all our assumption. These lines which are going, we can call them as functions. So what happens? I have got list of functions, and I give it to the machine to try out all the possibilities of functions. Let me try to make it here so that we will be more clear. So I've got input layer. I will try not to make it too complex. So this is input layer. Yeah. I'll take a simpler example after a while. And let's say I just introduced maybe 2 hidden layers, and I have got 2 output layers. So see, I can have 3 outputs also, 5 outputs or 10 outputs. In the case of numbers, I've got 1, 2, 3, 4, 5, 6. I have 10 outputs, right? It could be 0, 1, 2, 3, 4. If I'm interested in knowing whether this person is having diabetes or not, yes or no, then it has got 2 possible outputs. What happens? The data which I'm feeding, I've got existing data with me. So machine, what it will try to do is, it will try out this function, and it will arrive at some conclusion. Then this will try out this function also, it will arrive at some conclusion. Similarly, it will try out. So what is happening? Everything is being tried out. Everything is being tried out. And I hope you can just imagine what exactly I'm trying to make. So all the possibilities, and wherever I'm getting the best of the best results, the machine is going to learn. Wherever I'm the machine will tell you the probability, like probability of him being a diabetic, or probability of him not being a diabetic. So this is nowadays is very, very much possible, and it has been made very, very simple by using the ANN, which is artificial neural networks. Just let me try to play a relevant portion so that you can understand what I'm trying to say.
There are many, many variants of neural networks, and in recent years there's been sort of a boom in research towards these variants. But in these 2 introductory videos, you and I are just going to look at the simplest plain vanilla form with no added frills. This is kind of a necessary prerequisite for understanding any of the more powerful modern variants, and trust me, it still has plenty of complexity for us to wrap our minds around. But even in this simplest form, it can learn to recognize handwritten digits, which is a pretty cool thing for a computer to be able to do. And at the same time, you'll see how it does fall short of a couple hopes that we might have.
So I hope, in the very, very minimal possible time, I have been able to tell you that this is the kind of, by the way, multi-layer perceptron, this algorithm, there are different algorithms which are used in artificial intelligence and data science. And this algorithm, what I just described, is known as multi-layer perceptron. So I'll talk about some more algorithms also. So based on such things, based on the data, I can train my machines given certain data, whether the person is a smoker or not, what kind of pollution or environment he's staying, and the X-ray report, all these together, I can make a conclusion whether this person is having cancer or not. There is some statistics also you learn, like Bayes' theorem, etc., which is based on the conditional probability. We call it conditional probability. The person he's a smoker, and he's staying in a polluted environment, then what is the probability of him getting a cancer? So given the certain conditions, we are trying to calculate the probabilities of our desired event or the outcome. In simple terms, let us look at the simple terms. Using these artificial neural networks, I can train the machine. I can show different animals, and based on that, I train the machine. And once I train the machine, after some time, machine will start recognizing. Based on the features and based on whatever is learned, it will start recognizing the objects correctly. So that is about ANN. Now let me go into a little bit of, I hope this was more like very, very basic things. Now let me go, I hope, are you fine? Up to here you are fine? Can I go a little bit of deeper into what is supervised learning, unsupervised learning, reinforcement learning, and can I teach you certain algorithms? Are you ready to do that? I still have got 1 hour, right? Yes, okay. So thanks. So let me, with your permission, maybe in the next half an hour. So last 20 minutes I will keep for applications of AI in healthcare. So let me talk some terminologies which you will hear from many data scientists. So now let us see, this is, if I consider AI. So if I say this is AI, now when I'm talking about AI, do you remember what is AI? Anyone remembers the AI definition which I told you in the beginning? So I can say it enables the machine to think like human being. Sometimes I can say behave like human being also. So AI applications is our aim to develop an AI. Like for example, let us take an example, driverless car. Now driverless car is an AI application, right? Within that, we have got expert system, we have got NLP, etc. And within that, we also have got machine learning. Within that, we have got, yes, Omar, simulate human intelligence, absolutely. ML, machine learning. Now, what is machine learning? Machine learning is about statistical tools to explore the data. Statistical tools to explore the data. Okay. Here we have got different types of learnings. The first one is supervised learning. Supervised learning means what? Supervised learning means I use labeled data, and I train the machine using the labeled data, and after some time, machine will start predicting. I will just take an example. Suppose I show you one data like here. So we call them as features like blood pressure, glucose, BMI, age. Based on that, person has diabetes or not. Let us say 1 represents diabetes and 0 represents no diabetes. Okay. So this is known as labeled data. I have got a labeled data. So what I can do, I have got, let's say, lots of data with me. I can divide the data, means I'm just showing 4 here, there could be 400 as well. So I'll divide the data into, let's say, 60 to 70% of the time. I will use the data, 60 to 70% of the data I will use to train my machine. Let me take a simple example, because many of you may not be, may get overwhelmed with so much of data. Let me take a simple example. I give you, let us say, a simple data. Experience of a person in the, let's say I'm talking about, let's say, nurses, experience of nurses or hospital staff, let's say, and let's say age. Now I collected some data. So person with, let's say, 0 years of experience, age is 22. 10 years of experience, 32. By the way, anyone who's attended my black belt training before here? Is there anyone who has attended my black belt training before? Okay. Okay, no problems. So let me, so here age and I'm taking very, very simple example. Now this is a labeled data. Now I can collect a lot of data like that. Maybe people from experience of 5 years, 6 years, 10 years. And I divide this data into 2 or 3 parts. Just to make it simple, let us divide it into 2 parts. One is training data. So I use some data to train, some data to validate my model. Now, the reason I'm using a simple data and simple example, because all of us, and most of us, I still, I assume, must be remembering, if you go back to the school days, that if I've got the data like this, we call this as continuous data. Continuous means the numbers, 0, 0.1, 7.8, something like that. Both are data, with both the data are continuous data. I can fit this data into this model, which is known as a straight line, model of a straight line. So if I plot this data, this is the age, this is the experience, and if I plot the data, what will happen? 0 years experience, I am at 22. 10 years experience, I am at 32. 20 years experience, I am at 42. 30 years experience, I am at 52. Now let me tell you, my years of experience is 32. Can you guess my age? My years of experience, now can you predict my age? My experience is 32. What is my age? $54, yes. Allah, you're right. What happened was, this data was used to train, let's say, your mind, and you created, see, this we call it as algorithm. This is known as algorithm. Algorithm. This is known as algorithm. Now algorithm, based on this algorithm, what will happen? Okay, one of the question was here, yes, more data. Yes, more data, it will increase. More data will give you accurate results. You're absolutely right, Arva, you're writing. More data will give you accurate results. And I wouldn't go into the very much detail because I want to keep the things simpler here today. So but there is something called residuals and standard error. And by the way, all these things are very easy to, if you use Python, you don't have to, I'm just showing you some equations, etc. You don't have to really know these equations. These equations are like for I'm trying to explain the concept. That is why I'm using this equation. So this is an algorithm. And based on this algorithm, after getting trained in the existing data, I can create a model. What will be the model look like? Model will look like age is equal to Now, if I just see the value of A is, what will be the value of Y when the X is 0? If I make X is 0, what will be the value of Y? It will be 22. And what will be the value of B here? It will be 1. Means 1 year experience increase is going to increase my age by 1 year. So it will be 1. So my equation will be this. Now this I took a lot of time. I just did my if you go back to some statisticians, they can do all these calculations, but you don't have to do this. This is no longer required anymore. You just identify. Looking at the data, you identify, oh, this is a regression problem. We call it as regression problem. I have got some output data, which I label as Y, and I have got certain features. This is a regression problem. What I can do, I will just call a function in my Python language. I'll just call a function in a way. Let's say, Mr. Python, can you please do regression? Because I have to just identify. See, the only application of mind from our side is I should be able to identify the algorithm which is applicable to here. And suppose even if you are not able to identify, just try out every algorithm, whatever fits in. So this is a regression problem. As once you get trained in data science, you'll very easily identify this is a regression problem. So once you identify the regression, you can call that regression function and you can create this model. This model will be created automatically and you can then test the model. So you have divided the data into training data, then you can validate this and then you can test it. And once you find the test results are really, really good, means there was one like someone with 32 years of experience and you said it is 54 and actually I am 53.5, very, very little difference. And similarly, you'll have a lot of differences, residuals, we can say residuals or errors, we call it as errors also. So if my errors is very, very low, that means this model is a good model and I can use this for prediction. I can use this model for prediction. So now I need only experience. I can predict the age. I'll just took an example. Now we call this as labeled data because there was labels. And we call these as features. The experience, I can, like that there might be one person who's 10 years experience and I predict he's 32, but he says I am 37. Then I ask him what happened. And he said, I took a break. I took a break in between. So I will introduce one more feature here, which is the break time. So here break would be, break would be 5 years. And then I don't have to do any changes. The Python will do all these changes. And I will just put one more variable here, that is break time. Or maybe let me introduce one more. And when I have got multiple variables, I will say I am using multiple regression. So here I have got one more variable. Let me include one more. One person, let's say no break, 10 years experience. I predict the age as 32 and this person says, no, I'm 37. Then I further investigate and this person is a physician. Because physicians generally, till the age of 27, their experience is 0. So I just put one more variable, profession. So here I am saying no physician, this is not a physician, no physician, no physician, not a physician. But here the last one is physician. So I have introduced one more variable, that is physician. So I will just, machine will add, I don't have to do, machine will automatically detect it because I have told machine, please do a regression, multiple regression. Just by writing a function, we just say call a function. There are certain libraries available in Python. We have got the names of these libraries are NumPy, scikit-learn, Pandas, TensorFlow, which you can learn in, like, as I said, in just 100 hours of training, you can master all these things. And it's very easy. It's not difficult at all. You don't have to have any IT background. You don't have to have any mathematics or statistical background. You just need to identify the algorithm. That's it. It's very easy to identify nowadays. So I will just add, and I'll just put one more variable here. This becomes now new equation for my prediction. Now I will ask a person, okay, can you tell me how many years of experience? I have 10 years of experience. Did you take any break? No. Are you a physician? Yes. So physician becomes 1, yes. Then you are 22 plus 10 plus 5 years. So that means you are 37. So I have started predicting. Similarly, the output was in continuous format. I used regression and multiple regression. Now suppose my output is in, let us say, here the outcome is let's say, person is having diabetes. Yes, no, yes, no, yes. My output is in the categorical format. When it is in categorical format, I cannot use regression or multiple regression. I will use logistic regression. Let me tell you that as well. I hope you are able to understand regression and multiple regression. Just if you can write yes, it was not complicated, then I can do further logistic regression also. And let me talk about logistic regression. So logistic, let me keep it simple. So let's say age and person having diabetes. Age is 10 years. Person did not have any diabetes. Age 15 years, no. 20 years, no. 25 years, no. 30 years, no. But there are 30 years, I have got one person with diabetes as well. Now I'm just keeping it very, very simple. In reality, you'll get 20 samples of 10 years, 30, 40 samples of 15 years, and so on and so forth. 40 years, no. 40 years, yes. 50 years, yes. 50 years, yes. 50 years, no also. And then 60 years. This data is just imaginary data, so please take it that way. Yes. 80 years, yes. 80 years, maybe one person is no also. 80 years, yes. Now, if I want to make a graph of such a data, and I'm doing a little fast, I hope it's not complicating the matters. But what I will do, the output here is yes or no. The output here is yes or no. So I'll put it as 0 and 1. Okay. So we have got here age, and here I have got diabetes, yes or no. I can put either 0 as yes or no, whichever way I choose, that doesn't matter. So for example, at the age of say 5 or 10, no diabetes. No means 0 and yes means yes. Let's put that way. So no diabetes. At the age of 10, let's say I'm just 30, 40, 50, 60, 70. So I will get data if I represent something like this. I hope you are able to get what I'm trying to do here. So as the age increases, I have got more of yeses. Sometimes, a little bit outliers will be there. I can predict. Here I had used a straight line. Here I had used a straight line. Here I cannot use a straight line. We will use something called this S curve. Okay, let me ask you one thing. What is the probability of a person getting a diabetes if the age is 5? Can you tell me? Between 0 to 1. What is your guess? What is your guess? Person who is getting age is 5 is 0, yes. And 10, again 0. What is the probability of person getting diabetes if the age is 70? Between 0 to 1. Usually probabilities expresses 0 to 1. It is 1, I think. So, and what is the probability of a person getting the diabetes at the age of 40? Between 0 to 1, can you tell me any number? Just make a guess. It is 0.5. Yeah, so what is happening here is I'm getting an S curve. This is known as logistic regression. Yeah, and because it's binary, 0 to 1, so I will call it binary logistic regression. So what is my job as a data scientist? I have to just identify the kind of problem, the algorithm which will fit into this. And I have to just call that algorithm. That's it. It is as simple as that. I have to just call that algorithm. Okay. Yes. Now I have just used age. Now I can have multiple. Now here you have BMI also. I've got skin thickness also, blood pressure also, glucose. And I can develop my predictive models. I can collect a lot of data. I can train my machine. After that, I can validate whether it is able to predict or not. And so Omar is telling, so we are predicting number between 0 to 1 by submitting age only. I was just giving an example, but not necessarily on the age. You can add many features. We call it as features. And this is labeled data again. I can add as many features. And after that, if I have got this data with me, I can say whether what is the probability of this person getting diabetes, 0.8, 0.7. So if I fit my data there, the machine will predict, well, probability of you having a diabetes is 60%. Now, if there is like, I'm at 10%, 20%, there is not to worry much. But if it is 90 and 80, that means, well, I need to take some action. I need to start walking. I need to take care of my diet, etc. So this was just these two algorithms I just talked about. We still have time, I think. Yeah. So let me talk about one more. Has got supervised learning, unsupervised learning, like example for clustering. And then the third learning, which is known as reinforcement learning. Reinforcement learning is something like the one I gave an example of. A child learns by looking at the chocolate. So the best way to see this is, I think, look at this robot, how it is getting trained. Now I tell this robot, so what right now reinforcement means, if you are doing a good job, it will be reinforced. I'll give you additional points. And if you're not doing a good job, I'll give you negative points. So now I leave this robot, I construct a robot and leave it in the environment. And I tell, please learn by yourself. So it is trying its best. It's trying a lot of permutations and combinations. And based on these, and you don't have to remember these formula. I'm just telling a simple formula would be, if you're walking, +1. You're falling down, -2. If you're falling very badly, -5. Okay, now Mr. Robot, please go ahead. What will you see after some time? It is trying to maximize those scores. First, it will fall down, but after some time, it will start learning from its failures. And not only from its own failures, sometimes you can connect this to other robots who are also learning. So so many robots is learning from multiple friends, robotic friends. And then after some time, you start it's running, and not only running, but running so fast, it can beat any human being. And it can happen in just few hours of training, maybe 4 hours, 5 hours, sometimes 12 hours. So this is the kind of applications we are looking at artificial intelligence. Let me talk about one downloading writing your program very, very easily. Like, for example, I'll say print. Print, what do you want? Print means write. So here you have to learn a new element configuration distribution and just click on download. Download is available to everyone. You can just download it. So just to, I will not tell you to download these Python. We'll just show you some applications of Python, and it's very easy to download Python. Those who are interested, they can do that. But I'm just demonstrating here, just a quick video, and after that, we'll see you some. We'll show you. We have Rishabh who has joined with us. Now he will show you some of the applications in the retail industry. But before that, let me just take you through how Python looks like, because 80% of you are totally new to the area of data science. So let's just 2 to 3 minutes. I'll show you about Python and then we move on. It's download in your laptop very easily. Those who are interested, I can tell you how can you do that. Just type in Anaconda distribution in your Google. Just go to Google, type Anaconda distribution, and just click on download. Download for Windows or download for Apple computers if you've got Mac, and choose your relevant configuration. And after that, once you download, install it. It's very easy to install. It's like any other computer program. You download and install. It will give you all the instructions. And then after it gets installed, you will get a Jupyter notebook. You'll get a Jupyter notebook, which looks something like this. And now you can create a new notebook and you can start writing your program very, very easily. Like, for example, I'll say print. Print, what do you want? Print means write. So here you have to learn those things. Print means write. So print, welcome to the world of AI and data science. Okay. And if I just run it, it will print. It will write, welcome to the world of AI and data science. Another thing, if X is equal to 20 and Y is equal to, let's say, 50, print what? X plus Y. Okay, let us see. I'm asking print X plus Y. And let us see. Oh, it is 70. Now I'm just using simple things so that you understand. It is as simple as it's like English language. That is why even school kids are learning Python nowadays. Now, I understand that many of you have got 20 years experience, 30 experience. We are resistant to change. Oh, this is not my age of learning. Please understand there's a new kids on the blog which are coming out of schools. They would be much, much more smarter than you if you don't try your hands on these simple programming languages. Otherwise, you will get very easily impressed. But now, if you are aware of this, you will be able to ask the right questions. In fact, you don't have to write programs, but you can hire people who can write programs, but you'll have to tell them. Because if you have got the knowledge of the capabilities of these applications or softwares, you will be able to guide them, direct them. As a physician, you say, I'm demanding that you please write a program like this. I'm demanding I have got the data. Please, you give me a regression model. Please give me a binary logistic regression model. Or please apply SVM here. Or at least you will ask the right questions. So that is the kind of future we are looking into at this point of time. I would have, because of the lack of time, I wanted to do something more also. Like, for example, I have written name, name input. Okay, let me write it here so that at least you will be able to. It will save my time if you just copy paste here. Name is, I'm putting a variable, creating a variable is input, what is your name? And academy means, what is your academy? And if I run, it will ask me a question. It will ask me, well, that was about, very, very generic, I just wanted to give you a little bit of idea how a typical Python looks like. Now we have Rishabh. Rishabh, are you there? So I'd like to hand it over to you. And so Rishabh, if you can just show us. Now, I was talking about very basic things. And as I said, I'm more like a professor, not a practitioner. But we have a practitioner, Rishabh, who is like in and out. He's totally, he swims in data science day in and day out. A lot of applications, lots of applications he has developed. So Rishabh, yes, you can, if you can just take us through some of the applications.
Yes, thanks. Hi everybody. So today we are going to kind of land into retail analytics. So let me share my screen. Yeah. So we'll first try to understand a few backgrounds around this retail analytics, and we'll also try to understand that what all things that have changed. This is not a new topic which is coming for this particular industry. It has been there for a quite long time and years, but there are some changes that came over here now with the help of machine learning and data science coming into the picture. We are able to better understand our customer. We are able to better optimize our products, optimize our stocks, inventory, which earlier was more in a very traditional way. Okay, so there is a difference now. Like earlier, the approach was you have let's say a stock. Means you have basically items present in the stock, and you just go by which items are mostly sold in the stock out of this stock or inventory, whatever you say. Okay, so mostly sold items, and you keep on refilling those mostly sold items. Okay, now the challenge with this kind of approach is the product that are mostly sold has a lot of influence by its season, by its demand, by its different consumer, as well as the most important factor is local events. They create most impact. Okay, so local events in the sense local festival. Okay, those are the very impactful areas for any given retail store to sell their products, right? So these are the factors that we keep in mind before we actually go and build the analytics. So it is not always like you take an inventory item which is mostly sold and you keep on selling those same set of products every day, right? Your inventory should be powered with machine learning. Your inventory should be powered with AI to understand the most important product based upon these factors. Okay, season, local event, demand, and the consumers that you have nearby. So biggest retail chain, okay, let's say Walmart. Walmart is one of the biggest retail chain. Okay, now Walmart at Central Florida and Walmart at, let's say, somewhere at California, will have a different set of needs, okay? And at the same time, we'll have a different set of demographics. We'll have a different set of income levels, right? Different set of genders. So all of those things pile up in that particular region, in that particular location where you are actually doing the analytics for, right? So in any of this business, right, there are some factors which typically come from the business. So these are those factors, okay, which actually control your stock or inventory. So current state of the art was very traditional, very rudimentary in terms of calculating, let's say, how many items should be present in the stock. While using machine learning and data science, we are able to predict for every item, which first of all, we predict in two ways, okay? We predict that which are those set of items which will actually generate sales. So identify high sell or high shelf life products, okay? The second one is basically high shelf life doesn't mean the shelf life of that particular product. It typically means that the product which you keep on sell should be generating a lot of revenue in its own turnover and cycles. Okay, it doesn't mean the shelf life of the product. Okay? So we focus on the sales part of the product, and also we focus on what are the associated products that we want to put in. What are those associated set of products that we want to put in? So these are the two important aspects. One is sales, which shows that what are those set of products which are going to generate a revenue in next few weeks or months, and what are those associated products. Okay. So these are the two most important things. Let's say somebody coming and purchasing milk, okay, and along with milk, somebody purchasing bread. And this is a very most common associated product, right? So retail, so this is one part of retail analytics where we go and try to understand the different mechanisms that we can control the stocks and inventory. Okay, so the other part of the retail analytics is what type of consumers are basically visiting your store. Okay, who are those set of consumers for whom you are going to kind of get some customized offers. Most of the retail business, it is a part of the retail business that they typically launch some cyclic offers. Okay, so Big Billion Day is one of the biggest sales. Okay, these are the different sales event which comes. Big Billion Day, okay, where a lot of products are on sales. Okay, and similarly, like there are a lot of respective sales event which helps to get more and more customer in those particular events. Okay, now the idea of this is in two different ways. So first part is which are those products on which we are trying to give offers, the products which are there for a long time in our inventory, which are not getting a proper sell funnel. So over there we try to kind of leverage those set of products with higher, you can say, discounts. Now again, these are not done manually. Okay, these discounting a product is not done manually. Okay, because there are so many products. Okay, 1,000 plus, million plus products are there which are listed. So hence it is not possible to kind of go and label a particular product and give a particular discount. So we eventually go and predict the discount for that particular set of product. Okay, keeping the sales, shelf life, and all of those factors in mind, we eventually go and predict the discount rate. Okay, so this is one of the biggest, you can say, analytics that a lot of big retail giants, they apply most of the time. The other part is, so this is mostly on the D2C business. Okay, these are the algorithms which are applied mostly on a D2C business. Okay, the other side is, this is on the product side. The other side is, which are the consumers you should give offers. So let's say you have a consumer who is already spending a lot of money on you. Okay, so no point of giving a lot of offers because he's already being your one of the loyal customer. Okay, there is another set of customers who are spending in a cyclic manner, who are not spending daily but spending in a cyclic manner, and those set of customers have a potential of spending more. Those set of customers do have a potential of spending more. So hence, give an offer to those set of customers who have a potential to spend more, and they are not spending on a regular basis, they are spending on a cyclic manner. So most of the times, people do give offers to those who are sticking with the business. Okay, so those are very generic offers. Okay, but we also give offers. We try to figure out that which are those set of customers who has a high potential of spending. Okay, so we also call it as propensity to pay. Okay, we call in terms of analytics, we call it as propensity to pay. Who have a higher propensity to pay, so give more offers to them because they are buying it in a cycle. So let's say a person who is just buying 2 times a year and spending some, let's say $10,000. Okay, another person who is buying daily on a regular interval, on an average in an entire year he has only spent 500. So giving more offers might help to stick with this particular customer. Okay, but truly doesn't make always a sense, rather than giving an offer to those high bucket customers, okay, who has a higher propensity to pay. Okay, so that's one of the biggest analytics that people do run. Okay, and today I'm going to show you this particular higher propensity to pay, and how can you segmentize your entire customer. Okay, entire customer base. Given that with a very less amount of information, you only have a spending rate between 0 to 100. Okay, you have a spending rate. So let me write it here. So you have a spending rate. So 2 information is there. One is a spending score, which is between 0 to 100. Okay, 100 being the most, you can say the highest spend meant by the customer, and 0 being the lowest spend. Okay, because spend doesn't have a limit, right? It can be $2 to $20,000, even more than that, right? So hence we are bringing it down between a score of 0 to 100, so that we can easily bucketize all the large numbers in a particular range of 0 to 100, which makes any machine learning model really understand much faster. Okay. The other is, we have an income group. Okay, so the income tells us that this income is basically very projected income, okay, based upon the zip level. Okay, because we typically don't know the income for every customer, right? But what we know that in that particular zip level, who is having what sort of income. Okay, so somebody is staying at, let's say, California or New York. Okay, will have a higher income comparative to somebody staying at Atlanta. Okay, and those other states, right? So those are the zip level incomes, and those are mapped with the customers to understand that on an average, how much these set of people earns. Okay. And on the other side, we have a spending score, which is known to us because they're spending money on the store, coming and visiting to the store, spending money buying the products, right? So using these two information, we want to basically derive out how many different type of customers we are basically having in the system. Okay. And then we will try to understand what are those segment of customers. Okay. So now coming back to typically, I will show you this particular notebook. As I said, we have an annual income and we have the spending score. Okay. Between 1 to 100 or 0 to 100, whatever you say. Okay. We have a customer ID, we have the gender, we have the age, and annual income and spending. These two are more important. Okay. So we figured out that female and male is female, 56% of the customers are female and 44% customers are male. We don't have much amount of record, only we have 200 records. Okay, just a small sample of data we have taken, very small sample of data we have taken, and then we have done the analysis. Okay, and we have only consumed, and you see it is so self-explanatory. Okay, this is basically interquartile range. We call this as interquartile range, IQR we call this as. Okay. Now what is this IQR? It says that 75 percentile of the people are having a spending score of 73 and their annual income is also very high. Okay, and almost like it is normally distributed. Normal distribution means it's a bell-shaped curve. Okay, where all the values, where the mean is approximately equivalent to median. Okay, so these are some statistical concepts which comes in place to evaluate how the data looks like, what distribution the data is in. Okay, and those other concepts comes in the picture. Okay, so we actually covered this in a very broad term. So here we are just trying to squeeze it up so that it becomes much relevant for those who are non-techie guys. Okay, but in our course we actually dig in much more and see each of these parameters. How does it looks like? Okay, what are our outliers? Okay, outliers in the sense like somebody who is buying, let's say, $2 million product from a given store is just only one event and one customer, so we cannot consider that particular customer, right? Somebody like earning a lot of money which is out of our population, we cannot consider that, right? Because they're the outliers. We call them as outliers of the data. Okay, because their income is not you can say a stratified or a normal income of a given population, right? So if you take Elon Musk in your analysis and if you start taking his salary, then it's no point of using analytics, right? The income is very different and very large, right? So hence we try to exclude those. We have certain rules, we have certain statistical methods to actually apply those and exclude those set of populations mathematically and proving them as well, statistically proving them. Okay. In this particular data set, we have already squeezed it up and hence we don't have much of outliers. Okay. In fact, no outliers. We are checking whether there is any null data present or not. If there is any null data, we can try to impute that data. Impute means fill up that null values. Okay, again in a statistical manner. Filling up a null values is very different. It's again statistically we need to fill it up. Okay, so finally we are taking only these two columns, annual income and spending score. You can see dataset.ilog. All the rows. This colon means all the rows. And this 3,4 means third column and the fourth column. Okay, it's very simple. Python is self-explanatory. I'm forcefully explaining it, but if you look at it, it becomes very easy for you to consume. This colon means all rows, and this is the third column and the fourth column, and we are pulling all the values. Okay. Now what we are doing is we are putting into an algorithm called k-means, which what it does is it calculates the distance. So typically what it does is it creates a imaginary centroid. Okay, It creates an imaginary centroid C1 and C2, let's say. As of now, I'm taking 2 clusters. It can be 3, it can be 4, it can be 5, it can be 6. So you can see from 1 to 20, it can have 20 clusters, 20 different type of customers. But we have to choose what is the optimal different type of customers are present. So we have to run this for 20 times. And why we have to run this for 20 times? Because it is unsupervised. Okay, this is unsupervised problem. So we don't know how many different type of or different category of customer is present in our cohort, in our store, right? So we don't know, it is completely unsupervised. Hence, we are trying and hitting and doing a test and trying to identify what is the optimum number of cluster between 1 to 20. So I'm creating first with 2 cluster, 3 cluster, 4 cluster, 5 cluster, 6, 7, ... up to 20 different cluster. Now, out of this 20 cluster, which is the most optimum cluster, which makes a lot of sense to segregate these customer cohorts. Okay. So this is an unsupervised problem because I don't know. Okay. I want my algorithm to tell me how many different category of customers are there. So what it does is with 2, let's say it goes one by one. So with 2, it creates 2 imaginary centroid and try to calculate the distance for rest of all these values. Okay. With 3 cluster, it creates 3 imaginary centroid and tries to calculate the distance across all these values. Again, with 4, it creates 4 imaginary centroid and try to calculate its set of centroid, and 4 imaginary centroid and try to calculate its set of values. Now, what we try to do is we try to see whether this cluster C1 and C2 are significantly different or not. If they are significantly different, then we consider it. If they are not significantly different, let's say when you go to 5th cluster, 6th cluster, let's say, so I'm erasing this a bit. So let's say when you go to 6th cluster, now what happens? There are 6 different, 1, 2, 3, 4, 5, 6. So let's say the clusters are overlapping, you see, the clusters are overlapping. So hence, I cannot explain this particular cluster. So this is cluster 1, cluster 2, cluster 3, cluster 4, 5, 6. So I cannot explain 3 and 4 explicitly because there is an overlapping feature. There is an overlapping feature. So I cannot explain these 2 cluster 3 and 4 and eventually 5 and 6 because they are also overlapping. Right? So what are the clusters I will choose? I will only choose 1 and 2 because they are not overlapping. I am able to create a different insights from these 2 clusters, and 3, 4, 5, 6, they are all overlapping. So I will only choose 1 and 2, and I will actually label all my customers with 1 and 2 based upon its distance from its center. Clear? So this process is mathematically done, and behind there are a lot of mathematics which are going on. Okay. And we keep on doing, as I said, we keep on doing for all these 20 is the highest we have taken. You can also take 30, 40, but 20 means in any given data, there won't be any 20 cluster, right? It is well known. So hence, you basically take the data set and then you basically go and segregate it. 1 and 2 you can see, and you choose the optimal cluster by understanding whether you are able to segregate or whether you are able to create some differentiation between these 2 clusters or not. Okay, so I will erase the diagrams. So that's what we are doing here, and this is what we are plotting. Okay, this is called an elbow graph. What it does is it actually measures the significant difference I was telling, right? So this is cluster C1, this is cluster C2, and let's say this is cluster C3 and C4, they are overlapping, let's say. So it basically measures the difference from C1 to C2, C2 to C3, C3 to C4. Lesser the distance, we will stop we will stop choosing them. Okay. So now you can see over here, until 5, 1 to 5, the difference is very high. And you see post 5, the difference is too low. So we are going to reject all of these. We are only going to consider 1 to 5 because the difference is very high. Post 5, the difference is very low, right? Post 5, the difference is very low. Prior to 5, the difference is very high. So we are going to consider this 1 to 5 cluster, and we are going to reject 5 to 20. So ideally we have 5 different category of customers. Okay, so let us plot and see. Now we will basically go and level it out. So we are basically taking it 0, 1, 2, 3, 4. Okay, these are the 5 customers, 0, 1, 2, 3, 4. And now we are plotting it, and then this is how our customer cluster looks like. Now let me explain you. So you see annual income 0 to 150. Okay, and spending score is 0 to 100. Okay, now what we are doing? We have created 5 clusters. The blue ones are basically known as centroid. These blue ones are basically the centroid. Okay. The first observation is each of these centroids are significantly far away from each other. Each of these centroids are significantly far away from each other, which is very good. Okay. Second, let us explain each of these clusters. So this cluster, the yellow one, who earns between $0 to $40,000, and their spending score is also similar. So I can say earning is equivalent to spending. Earning is equivalent to spending. See the green ones, their earning is moderate and their spending is also moderate. So earn moderate, spend moderate. Okay. Earning is moderate, spending is moderate. Now you can say that these 2 clusters are explaining the same thing, right? But earning moderate and spending moderate will have those people who are earning moderate, they have a different needs and demands. Their products are also different, right? Their demands, the brand they use is also different rather than those who are earning the least, right? Hence, there will be a difference in their product choice, difference in their spending capability, difference in their the entire sector. So hence, the green ones are basically earn moderate, spend moderate. Come to this blue one who is earning less, spending very high. So these are the customers who are in debt. They're purchasing, they're taking the product by taking loans. The debt ratio is very high, right? So hence their earning is less, but their spending is very high. You see this customer, the red ones, their earning is very high, spending is very low. So these are those set of customers who have a higher propensity to pay. These are those set of customers who have a higher propensity to pay. So if I give more offers to them, then they can jump into this orange cluster. The orange cluster is basically earn high, spend high. Earn high, spend high. So this is my ideal customer. Okay. They have a higher propensity to pay and they're actually paying, they're actually investing on me. So I want this red cluster to go and jump into the orange cluster. Right? So I will give more offers to these red folks so that they buy more and they slowly start migrating from red towards orange. So this kind of analytics we try to do, and we will basically figure out who are those set of customers who are red. And this is how we do the analytics and segment and bucketize our customer and try to relate how they are actually differentiated. Right? I'll show another example where we are choosing more than 5 clusters. So you can see here we are choosing more than 5 clusters. Now, what are your observations? This particular cluster and this particular cluster, which was earlier the same group, earlier it was same, but now it got splitted into orange and blue, making no sense. They are also earning high. Orange is also earning high, blue is also earning high, spending is also high. So I have 6 clusters, but this is not making any sense because the clusters are overlapping. The clusters are overlapping, hence it is not making any sense. Clear? So you have to choose optimal number of cluster, and based upon that, you have to actually do the analysis and figure out that what is the sense that your actual model is talking about. So this is my ideal analysis, and we finally present this to our different business stakeholders. And then after the rest part of the things are done, and we basically go and choose respective stakeholders and choose these respective customers as well. Right? So this is how we perform retail analytics, and it has different segments. So I spoke about discounting, I spoke about inventory management, I spoke about customer segmentation. Then there is another part which is advertisement management, okay, which is completely different. So there are different areas where we go and apply AI, and most of this entire analytics is now going to get in full phase, so that a lot of the business decision earlier which were taken manually, now they are going to be taken by using this data science, by using the decision of these models. The model will decide whom to give offers and whom not, what products to give offers, what discount, what product should get into a discount, how much discount we should do. All of those information model will basically define. Here, so this is the next gen of retail industry. Okay. Any questions, any doubts that you guys have? Go ahead.
Great. So thanks, Rishabh, for telling us the real, I would say the real application, and you are the guy in action always. So, and every time, for all participants, every time Rishabh comes up with a new application of the data science knowledge. And last time we talked about, I think, healthcare. Once we talked about, yes, Rishabh can remind me. What are you can watch.
We talk about ChatGPT.
ChatGPT, yes, ChatGPT. Last time it was ChatGPT. So if you are interested in, watching those videos, they're all available on the Anexas YouTube channel. And the best part, or the best, progression from here would be to join our data science courses. These are the topics. Of course, this is not the exhaustive list, very, very high level. The topics, Python, NumPy, Pandas, these will make you a master of data science. There are 3 levels: basic levels, intermediate level, and advanced level. And if you do advanced level, you would have mastered all the topics of data science. But you can start with the beginners level first. And we also have last 3 months of the recruitment. We have a recruitment drive for the students, and we have done 100% placement for the past 5 batches. And we also prepare you for the interview and job profile readiness for the job seeker.